One. If a thing exists, its architecture exists. Whether or not we know what that architecture is, whether or not we have made it explicit. If we don't know what it is, then we make assumptions about it. Certainly, sometimes those assumptions are right, and sometimes they're terribly wrong, as we have seen from what has happened to some of our major financial institutions over the last few years, because they were making assumptions, and in fact those assumptions turned out to not be very good. But if we do know the architecture, then it becomes a model or a representation of that object. And we need that architecture very often in order to be able to see complicated things or big things, or sometimes things that are too small to see, so we can communicate about them, or so we can do something with them. And this is especially important with big and or complicated objects like buildings and bridges, highways, airplanes, computer chips, and of course, organizations. Now, Michael, how do I control this baby?
Just click that
down button. Okay.
The down button. There you go.
All right. Well, let me get that slide back for everybody. Yeah, I'm in Texas. We're a little slow here. I'd like to thank everyone for being here this morning too. So why do we do this? Well, because big, complicated objects can't really be seen directly. They can't be seen all at once. And they often require teams in order to build them, to change them, to manage them. And teams require communication. You know, we're in the process of putting up a new College of Business building here at the university. Well, there was a large, long-term process that went on in order to get the requirements understood, the drawings, so that all the different trades and subcontractors, so the hole was the right size, and the foundation was poured properly, and the furnishings were the right ones, and you know, just so many different things that need to be communicated from conceptualizers and decision makers and owners and users who will eventually, you know, populate the building, to those who will actually put it all together. We need architecture to do so many of the things we do. Let me share a metaphor with you and see if that helps us understand this better. Hopefully it'll illustrate this issue. The current state of management, not just of IT, but of organizations in general, and really of how we approach public policy, how we deal with medicine, so many things, is much like the alchemists of the 17th century, who tried to classify all the compounds they could identify. It turned out to be a fruitless enterprise, because there's an infinite number of possible compounds, and compounds could be in, you know, every allocation scheme was fairly arbitrary. Compounds could be classified into more than one of the categories, because by their very name, compounds are made up of lots of different, what we now call elements. In the 1850s and 60s, this began to shift to attempts to actually try to classify elements. And in about 1869, Mendeleev actually classified the elements by their atomic weight and their valence, basically the number of bonds, all right, by a physical property, by something everyone could agree on. And that by understanding the elements, the physics of chemistry could be understood, because now they understood the metaphysics of chemistry, the essence of it. And the result was we had a periodic table, and now we could predict new elements. We could predict things that hadn't even been discovered yet. We could predict new compounds. We could predict the behavior of those compounds as well as those elements. And the world changed. Once Mendeleev published the periodic table, chemistry became a science. Before the periodic table, there were only best practices. There was alchemy. There was no science. That is the state of management today. And those who build information systems, which I presume is most of us online today, we really do understand this. I'm going to have to quit using my page down button here. As do those who build buildings and those who manufacture things, because we understand that we have to know where we're headed. Do you see my cursor?
No.
Okay, then I'll quit pointing to things. Although it helps me see where I am. Fred Brooks talked about this, and we'll talk more about Fred shortly. But Fred's a computer science professor, but Fred became famous as the project manager of IBM's 360 operating system in the 1960s, at its time the most complicated piece of software, and wrote the book The Mythical Man Month based on that experience. But later he spoke of the essence versus the accident of building software, the essence being knowing what you're going to build versus the accident, the managing of risk in the delivery of it, or the distinction between the planning and design versus the delivery. Architecture is about the part that's circled, and obviously if we make a mistake in that first part, in the essence, then the cost of that mistake is much greater, much more difficult to fix, et cetera, going forward. And certainly those of you who have been involved in information systems projects understand exactly what I'm talking about. Let me give you an example. Okay. Now this is the C-level person's view of the architecture of this particular enterprise, which happened to be about, at the time, a $20 billion IT services company. As you can see, the top row is kind of strategic things, kind of logical things, strategy, lines of business strategies, all right? The middle row is kind of business model things, service portfolio, processes, locations, initiatives. And the bottom row is, mostly IT things, physical things. So you can see how it goes from logical to physical, and it's in a very intuitively pleasing format for management. It's file folder. So the CIO of this organization was upset with their database management system vendor and basically said, we got to get rid of these clowns. I don't like the way they treat me, or I don't like the way they treat this organization. Let's see how hard it's going to be to replace them. Okay, well, as expected, lots of data stores and applications are dependent on this DBMS, but we know how to do this. We know how to phase things in. We know how to stage conversions like this. This is manageable for us. Could take us 12, 15 months, but I can see how we could definitely do this. Let's see how this. Let's see what the implications of these systems are that we're going to be changing to the rest of the enterprise. Well, that's a different picture now. I can see that this project would basically put everything at risk. This is not a risk I can reasonably take on. And in fact, what the CIO could see is why, what he obviously had not seen before, was that he was in a relationship with a business partner that was not going to be easy to ever get out of. And so he needed to really change his whole approach to it. Because obviously the vendor understood that this partnership was very difficult to change. And so, look, I can't get out of it, so what can I do as the CIO? Well, he brought in his attorneys. He pushed back a little bit. He got some changes in how things were managed, and he let the partner know that, hey, you can't push me around anymore. I understand the situation, and they continued to have a much better working relationship even to this day. So the idea of architecture is really the idea of being able to see things better. It's really the idea of applying engineering and architectural principles to organizations. And this is really,